Okay, so I was asked to do an overview of chemical bonds, and there are 6 main types that I want you to be aware of, listed in order of strength. And the first one is covalent bonds. Covalent bonds are the strongest type of chemical bond, and they involve the sharing of electrons between atoms. An example, and this for especially AP biology students is one of the most important examples, is in water. So in water molecules, you have a hydrogen atom that is covalently bonded to an oxygen atom. So let's pull up our periodic table. We can see that our oxygen is 2 away from being a noble gas, so that means it has 6 electrons in its outer Lewis structure. Our hydrogen atom only has 1. So you'll see our hydrogen atom here and our oxygen atom with our 6 electrons, and it's going to form a covalent bond. We'll get another hydrogen atom on the other side doing the same thing. So that's how we have our structure for water, which is H2O. So that's for our covalent bonds. Now let's have a look at the next type of bonding, which is going to be ionic bonding. So that's the next strongest type of bond. And this one is when you have electrostatic attraction between 2 oppositely charged ions. The ion can be either an anion, which has a negative charge to it, or it can be a cation, which has a positive charge to it. So cations are positively charged. And one very easy way to remember this is remember that anions are like onions, anions, and they're bad or negative, and cations are like cats. And if you like cats, then cats are positive. I'm a dog person, but this is just an easy way to remember things. And this electrostatic attraction is going to be based on the electronegativity of the 2 atoms that are involved. So, for example, let's say we have sodium, and if you remember, since it's all the way to the left of the periodic table, it's going to be a lot less electronegative than its counterpart chlorine, which is all the way to the right. You can see how the trend works on the diagram that I've put here. So we have sodium, which is a cation, and chlorine, which is an anion. Sodium has a +1 charge to it, so it's willing to donate its extra electron to chlorine, which is much more electronegative. Chlorine wants to take that electron away from sodium. It's an anion, and that's how we get that bond forming there. So you'll always see a more electronegative atoms wanting to steal electrons from the less electronegative atoms. It's kind of just how that works. So then we have the next type of bond, the third strongest, which is the metallic bond. And actually, before I continue between anything, I just want to note that the covalent bonds typically occur between 2 nonmetals, or atoms with similar electronegativity. Just as we said before for the ionic bonds, they typically occur between atoms, such as metals, and nonmetal, which have differences in electronegativity. Now we have metallic bonds, and those are going to be found in metals. So those are metal-metals. Metal-metal bonding. Electrons in these types of bonds are delocalized, so they're free to move throughout the structure. And this is really important because this is what helps to give metal a lot of its very special properties, such as being able to conduct electricity or also be very malleable or ductile. So it's very interesting. So for example, copper is a really good conductor of electricity. So you'll see most of our wires in our house, they're made of copper, and your lamps and things. So say I had a piece of metal copper, which is made out of a lot of copper atoms, and I apply a charge to it, a negative charge on one side, you're going to see all the electrons being delocalized and able to flow freely. So they're going to flow from the negative side to the positive side. if I have a positive charge at the other end of my wire. It's because of this metallic bonding, this delocalization of electrons, that we get current to be able to flow. So that's how we have our electricity flowing through our copper wires. Okay, so the next type of bonds that we're going to look at are also very, very important for AP Bio students and life in general, and those are hydrogen bonds. So hydrogen bonds are attractive forces between a hydrogen atom, which is covalently bonded to an electronegative atom, and another very electronegative atom. So that's quite a mouthful, so I'm going to underline in red what I mean. So we have the hydrogen atom that's covalently bonded to the electronegative atom, just like we saw in water, how hydrogen is covalently bonded to oxygen. And I'll draw that in red for you to see for those bonds. Those are covalent bonds. Don't mistake that those are hydrogen bonds. Those are covalent bonds. The hydrogen bonding is going to be the attractive force between another oxygen atom, that's your other very electronegative atom, which I'm going to circle in blue, and its desire to take away that hydrogen atom is going to be your hydrogen bond force. So that oxygen's wanting to take that electron from the hydrogen, and we'll see it kick off the other, and that is your hydrogen bond. It's what makes water very sticky. All these really electronegative oxygen atoms floating around, wanting to attach themselves to hydrogens of the other water molecules. And it's very important too if you look at capillary action. So water interacting with water is very cohesive, but its ability to form hydrogen bonds makes it very adhesive to other surfaces. So it can hydrogen bond with molecules in the glass and cause them to crawl up. And in plants, this stickiness is what causes water in the roots of the plants to be sucked up by this capillary action to adhere to the sides of the little tubes inside the plant and be sucked up from the soil into the roots. So water being very sticky is due to hydrogen bonding, and that is why it is very important for life. So when you see the chemistry of life section, this is why water is very important, and it's going to be covered in your AP Bio exam. Okay, so next we have the dipole-dipole interactions. So say I have an atom of, or a molecule of hydrogen chloride. The chlorine, being very electronegative, is going to have a negative dipole moment, and the hydrogen is going to have a more positive dipole moment. So if I took two molecules of hydrogen chloride and I stuck them close together, the negative dipole moment is going to be attracted to the positive dipole moment. So the chlorine side is going to be attracted to the hydrogen side, and we'll see an intermolecular attraction. And that is what a dipole-dipole interaction is. These are important in biology for protein folding. So you'll see later on that proteins are just long chains of amino acids, and there's going to be positive dipole moments and negative dipole moments inside those chains that will cause the structure to fold. So it's very important in protein folding. So dipole-dipoles occur between molecules with permanent dipoles. So we'll see the positive end attracted to the negative end. So the positive end of the dipole moment attracted to the negative end. And last but not least, our weakest type of forces are van der Waals forces, also known as London dispersion forces, so don't get thrown off if they show you two names. And they occur from temporary fluctuations in electron distribution. So basically we can have just your normal run-of-the-mill atom, and for some reason, because we have electron clouds, let's say the electrons temporarily want to move to one side at that moment in time. That would leave the other side of the atom a little more positive. So we would get what was known as a temporary dipole moment. You'll see that the positive side of the atom is going to be attracted to the more negative side of another atom that comes around nearby it. So this is very weak because it's very temporary. It's not permanent like the dipole-dipole interaction, but it does occur. And that's why we see these attractive forces when this does happen. So these are our van der Waals, London dispersion forces. Okay, I hope this video was helpful. Remember again that these are all ordered by strength. So a lot of times they might ask you what type of bond is in this particular molecule, and you'll have to be able to answer that. And sometimes they may ask you questions like which molecule has stronger bonding forces to it. So you'll have to answer questions that are like that. If you want to have practice problems for these, please leave me a comment down below and I'll be more than happy to provide them to you. Or if you have any other topics that you'd like to see, please let me know as well. You can also support me on my Ko-fi page. All my videos are free and I make them whenever anybody who needs help requests them. Thank you and have a wonderful day.